Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discussing about the retrosynthesis and the synthesis of some of the target molecule. So far we have discussed about the 5 to 6 target molecule. Let us look at as a target molecule number 7 over here. 7, consider the target molecule. Let us see here the target molecule is this one. Let's see this one. This is a target molecule number 7. So first of all, what is our business to do? Here we have to do the retrosynthetic analysis, right? This is the first part. Retrosynthetic analysis, as we know that usually the process of breaking down target molecule into convenient starting material using disconnection and FGI is known as retrosynthetic analysis. And retrosynthesis means what? Retrosynthesis is different than the retrosynthetic analysis. Always remember both two words are different. RESA means retrosynthetic analysis and RES means the retrosynthesis. Retrosynthesis means what? An imaginary but logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as retrosynthesis. Or now here, what is the first thing to find out here? You identify the functional group present in the target molecule. Look at this target molecule. Observe this target molecule. After observing this target molecule carefully, what do you see over here? This is the carbonyl group, that is a alpha beta unsaturated compound is present, right? And now you can show the disconnection arrow, or you can write FGI over the disconnection arrow. And we know that disconnection means what? An analytical operation which break a bond and convert a molecule into convenient starting material into a possible starting material is known as disconnection. And the functional group interconversion means what? One of the functional group is converted into another functional group so that disconnection becomes possible is known as a FGI. After doing that, you are going to get over here C double bond O. At beta position I am putting as a OH, hydroxy group over there, and as we know that this is nothing but as a aldol, right? This is alpha beta unsaturated compound, alpha beta unsaturated ketone, this one. And as we know that this we can break like this. Here is a negative charge and you are going to get O, a minus charge over there, and here you may get this one hydrogen atom placing ion over there so that you can clearly see the aldehyde group. And this is known as a synthon, right? And as we know that synthon must have a synthetic equivalent. The synthetic equivalent for this I am writing here, synthetic equivalent will be here C double bond O. I am placing hydrogen atom, that becomes as a CS3 group, and then C double bond O, that is hydrogen atom. This is a synthetic equivalent because this has a synthetic equivalent and this is a reliable synthetic equivalent. Here is a Mg and Br, not the hydrogen atom. Now make it clear over here, or what we can call it as a CS3 group. You can place hydrogen, doesn't matter over there. This is a synthetic equivalent. So this is about the retrosynthetic analysis. Now start the synthesis over there. Second part will be the synthesis, right? Synthesis. Here we got, this is a starting material, right? And this starting material, as we know that the starting material C double bond O, then we can write over here C double bond O H, right? And now I am using here sodium ethoxide, which is a base and which will abstract the highly acidic proton from here. OET minus will pick up the proton and form as a carbanion, and you might be noticing that this is a intramolecular aldol condensation reaction, and so that you are going to get here C double bond O minus charge over there, and then here double bond O, and this hydrogen atom I am placing as it is, and now this can be shown like this, so that you will get as a double bond over here O minus, and that type of the species, as we know that this is a enolate, right? This is a intramolecular type of the aldol condensation. Here we can show as a intramolecular approach, intramolecular aldol condensation over here. And now here what is going to happen? These double bond, these negative charge forming double bond over there, and this double bond attacking on that carbonyl group, and you are going to get this type of the that is a cyclization takes place over there, double bond, and there at this position O minus, right? And now after that hydrolysis H2O in presence of the H plus, and this alkoxide group can be pick up the proton from solvent, and you may get as a this is not that you are going to get as a aldol over there like this. Here you get C double bond OO, and here H. Now just heat it, as we know that, or concentrated H2SO4 you can use, or there is a dehydration reaction takes place, you may get as a target molecule here. This target molecule is nothing but as a this one, C double bond O, double bond is over here. So in this way we can prepare, we can synthesize as a target molecule like this, right? So this is a 7 number target molecule. Let me give one more example over here. Let us clean the board first. Let me clean the board first, so that I can show the another target molecule, which will be the target molecule number 8, I think, over here. Now I am placing that target molecule here. I am considering that target molecule here is a 8 number. Now which one will be the target molecule number? This one. Let us see over here. Here I am writing this type of the compound, and here generally this type of the OH, right? This is our target molecule. What are the things to observe in the target molecule, right? This is the target molecule, right? First thing is a retrosynthetic analysis. Do the retrosynthetic analysis. This is the first part. In a retrosynthetic analysis, and as we know that, first observe the target molecule carefully. What do you see? There is a one group disconnection, as we know that. This is a alcohol. What type of the alcohol it is? It is a tertiary alcohol, right? Tertiary alcohol, and look at the group tertiary alcohol. This CS3 and one cyclohexyl groups are present. So this is the tertiary. There are the two possibility, two route you can apply over here. So in this way, let us see here how we can break this one, the methyl group over there, and you are going to get here this type of the compound. Now C double bond O, this type, and plus CS3 minus charge over. You are going to get another, and here this is a synthon, right? And that synthon must have a synthetic equivalent here. You can use Br, then Mg and the CS3, right? So this type of this is called as a synthetic equivalent for this, and as we know, this is a compound we can get over here, or this can be obtained from you know that you do the FGI, functional group interconversion. After doing the functional group interconversion, you may get over here, this one is a second. Now it is alcohol, but it is a secondary alcohol. There are two possibility again. It can break like this, so that we can show here the disconnection may be again is a same, not same. Here you may get is this type of the compound C double bond O, then H over here aldehyde type of the group, and then CH3 minor charge, and this is a synthon, and this synthon must have a, this is a synthon we got here, and that synthon must have a synthetic equivalent CH3, Mg and the Br. This is a one way of doing the retrosynthetic analysis. Now let us see here is a B way, B route. So suppose as a this one, this is the same way. If you break like this, you may get over here negative charge and plus C double bond O acetone. So that is a synthetic equivalent we got, and the synthetic equivalent for this will be the this one. You can attach over there MgBr, which is a Grignard's reagent. This is a synthon, and this will be the synthetic equivalent, and this can be obtained from this one bromocyclane or cyclobromine, and like this. So in this is a whole analysis of this target molecule. This is a retrosynthetic analysis we have seen over here. Understood this one? How I am showing there are two routes are there. By showing as a two route, you can get as a this type of the starting material. The aim of this retrosynthesis to arrive at the starting material or the precursor. From that we can easily synthesize the target. Now let us look at as a synthesis now here. Synthesis, I am starting from here, the synthesis over here. Now A route synthesis. Now I am doing as a synthesis over here. First one is A route. A route, which route I am going to apply over here? Here, right? So I must take here CS3 Br, that will be treated with magnesium metal in presence of dry ether. What I am going to get? Here I am going to get this one CS3, then MgBr. So that is which is a Grignard's reagent, right? And this Grignard's reagent I am going to here, let me clean again. So this is a Grignard's reagent I got over here. Now this will be treated with this one C double bond OH. This is a aldehyde type of the group, and now it is going to attack over there, so that I am going to get here let me draw O MgBr, and this methyl group, and this when I am treating with hydrolyzing it in presence of H2O and H plus, what I get over here? This one OH, then this methyl group, and further this is I am treating with K2Cr2O7 in presence of dilute H2SO4. What is going to happen? That secondary alcohol get hydrolyzed, I am get oxidized, I am going to get this secondary alcohol is get converted into as a this one, and now I am further treated with this one CS3 MgBr, which is a Grignard's reagent. Now it is going to attack on that carbonyl group, so I must get over here this one. This is a OMgBr, this is a methyl group, and this is another methyl group which is from Grignard's reagent. Now I am going to add over here, what I am going to add over here is a hydrolysis, just H2O in presence of H plus. I must get as a target molecule number 8, right? Got it? Just hydrolyze it, you will get as a tertiary alcohol, which is this is a route, and by using as a B route, so here I am showing over that B route over there. So this is the starting compound I have taken, that is a bromocyclohexane, that will be treated with magnesium metal in presence of dry ether. Why I am using dry ether? I already told you that the reason behind it to avoid the accident or that catches the fire if the moisture of waters are there, and then you are going to get here MgBr, and this will be treated with the acetone C double bond O followed by hydrolysis H2O in presence of H plus. What do you get? You are going to get resulting compound is a target molecule here, tertiary alcohol. This is another way, and that will be the better way. Number of steps are decreased, and there is a high yielding possibility of that compound. So this is what we can call as we have seen as a target molecule number 8. Now let us see the next one. Let me clean again that board so that we can see the clear cut retrosynthesis as well as actual synthesis of those molecules. Now let us see over here the another molecule which I am, that is molecule number 9, I think this one. So let us see over here. This is the molecule which is given in the book. So whatever molecules are given in the book, that I am considering, I am taking over there. This is a compound, this is our target molecule. Now first of all, while doing as a retrosynthetic analysis, RESA, retrosynthetic analysis, what are the things to observe? When you see the molecule, when you observe the molecule, first identify the functional group in the target molecule. Here is a functional group Br. So this you can do the FGI, functional group interconversion. This halide group you can convert into as a alcohol, as we know that, right? Then CH2 and the OH. Once you got the alcohol, it is the easiest way to disconnect that bond like this, and so you make it here the compound, this one CH2 minor charge and one the HC double bond O, that is, and this is nothing but as a synthon, as we know that synthon is associated with the polarity, and it must have a synthetic equivalent. Can you tell me which will be the synthetic equivalent for this? Yes, it is a minor charge over there. You can bring over there, that is a CH2, Mg and Br. And as we know that MgBr we can obtain from this benzyl bromide like this. Once you have this one, CH2 and Br, right? In this way we can prepare that one. So this is a retrosynthetic analysis. Now do the synthesis. Second part we know that it is a synthesis, right? And after the synthesis, how do you do that synthesis? Let us see. Synthesis again is very easy. You start from this one. So as we know that this is a starting material, phenyl benzyl bromide Br, that will be treated with magnesium bromide in presence of dry ether. Resulting complex is known as a Grignard's reagent. I am writing as a pH, then CH2, then Mg and Br, this one, right? And now this compound I am further treated with formaldehyde C double bond OH. This is the first adding, and second one I am adding here H2O in presence of the H plus. What I should get here? We are going to get pH, CH2 and the OH over here, and this I am further treated with PBr3 or PBr5. What I should get over there? pH, CH2 and the Br, which is our target molecule. That's it. So in this way we can synthesize any target molecule which are given in the book, right? So in this way we can prepare the synthesis of any target molecule which are given in the book. I think we have considered near about as a 9 target molecule over here for synthesizing, how you can synthesize this type of the target molecule. So if you do this once again, let me tell you one more example over here, and after that I am going to tell you what are the important thing you should remember while discussing, while assigning that retrosynthetic analysis. Let us see the molecule number 10 over here. So that is a target molecule number 10. So which molecule I am going to take most of the time? We already taken this compound, one more is remaining over here. So let us see this type of the compound over here connecting as a this one. So let's see over here, this is a target molecule, I think C double bond OH. This is our target molecule, not 5-membered ring, not the 6. This is a 5-membered ring, this is a target molecule. Now how should I show? The first thing is a retrosynthetic analysis, right? Retrosynthetic analysis, first do the FGI. What is the first thing to do? Recognize, identify the functional group present in the target molecule. If you observe this molecule carefully, what do you see? There is a carbonyl groups are present, and therefore you can convert this carbonyl group into OH, alcoholic group, right? Here like this, or in this way you can represent this CH-2 and OH like this. And once you got the alcohol, we can do the retro of this in this manner. So here you will get negative charge, and one more compound is a formaldehyde, and this is known as a synthon, right? And this synthon must have a synthetic equivalent. The synthetic equivalent represented by 3 lines, and you must get over here is a Mg and Br, right? And once you got this Grignard's reagent and this Grignard's reagent, we can obtain from this compound, let us see this one, that Br, which we have seen just now. Now let us start as a second one is a synthesis. Synthesis again is a very easy. Synthesis start from this starting compound which is here, right? Then Br plus Mg in presence of dry ether. After doing this, the resulting compound organometallic is obtained, is called as a Grignard's reagent. Once you got the Grignard's reagent, it will be treated with formaldehyde C double bond OH. This is a formaldehyde, and after doing that, what is going to happen? Again, as usual, this is going to attack on that carbonyl group. You are going to get over here this one OMg Br and this hydrogen atom, and just hydrolyze it H2 in presence of the H plus this compound, this complex break, and you are going to get over there is a OH. This is nothing, this is a alcohol, and now this compound treated with K2Cr or for aldehyde you can use as a PCC, and PCC, as I already told you, that if you use as a PCC, primary alcohol is stop at a aldehydic position, and therefore we are going to get the product over here like this. So these are the, I think, most of the example I have shown over here. Now let us see what are the important question may appear in an exam. One more question may appear like this: define and explain the synthon. We know that one, or explain the term FGI with a suitable example. We have seen number of examples, suitable example we have seen. Then there may be as a write the disconnection approach and synthesis of 2-butanol or crotonaldehyde, 2-phenylethyl benzoate. So that type of the, write the retrosynthesis and synthesis of that some of the molecule like this. Write the disconnection approach and synthesis for 2-butanol, or write the synthesis for different molecules are there, is given over there, or define and explain the following terms with suitable example like as a disconnection, synthon, functional group interconversion, synthetic equivalents, target molecules, reagent. These are the things you have to remember as far as this chapter is concerned. I think with this I have discussed whatever the important, whatever the necessary thing required for retrosynthetic analysis, and I have taken number of examples for understanding as a this what we can call it as a this chapter fully. So I think we have completed this chapter, retrosynthetic analysis and the application, and there what are the probable question may appear in the exam, that also I have discussed over here. So tomorrow onward we are going to start the new chapter. The name of that new chapter will be the rearrangement reaction. So let us stop today here. Have a nice day. Thank you.